For section 4.4, we are still talking about triangle congruence, but we're going to talk about side, 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 and side angle side postulates. So first off, here's a vocab word of triangle rigidity. Gives you a shortcut for proving two triangles congruent. So next is our postulate side, side, side congruence. So that is where all three sides of our triangles are congruent. So if all three dimensions are given on both triangles and they're the same, they match up, then we can say it is congruent by the side, side, side congruence postulate. So for example one here, we have to use the side, side, side to explain why triangle PQR is congruent to triangle PSR. So first thing is it's labeled over here that PQ and PS are congruent. So we can say that PQ is congruent to segment PS, and that's given by those tick marks there. And then also the two tick marks indicate that those two sides are congruent. So QR is congruent to SR. Let me say that's given. So the only thing that we have to prove then is that this side of the triangle on both triangles is the same. So PR is congruent to PR, and that is the reflexive property of congruence. And remember, that says that any shape is congruent to itself. So because this line is the same line on both triangles, we can say because of the reflexive property of congruence that those are the same. And now we have all three sides of the triangle proven that they're congruent, so that we can now say that triangle PQR is congruent to triangle PSR due to the side, side, side postulate. Another vocab word here is included triangle, and that's an angle formed by two adjacent sides of a polygon. So the side AB and BC form the angle B. So that is what's called an included triangle. Then we have side angle side, the congruence postulate here, and that is when we have a triangle and we know that in the order here, side, then an angle, and then another side is congruent. So what I mean by that is here's a side, then an angle, and then another side is congruent. And those are labeled and given, so then we can say that those two triangles are congruent based on the side angle side congruence postulate. So for example 2 here, we have a picture that's showing the support structure of the Statue of Liberty, and we have to use side angle side to explain why triangle KPN is congruent to triangle LPM. So looking at the picture there, the sides that have one tick mark are congruent, that's given. So KP, segment KP is congruent to segment PL, and that's given by that picture. And then the other ones that have two tick marks are NP, and that would be congruent to the other one, which is PM, and that's given to us. And since we are told we have to use side angle side, we need an angle in here. So these two angles have to be congruent. And those two angles are what we call vertical angles. And we know that vertical angles are congruent. So we can say angle KPN is congruent to angle MPL based on the vertical angles theorem. And now we have a side, then an angle, and then a side labeled congruent in our picture. So we can say triangle KPN is congruent to triangle LPM based on side, angle, side. For example 3 here, we have to show that the triangles are congruent for the given value of the variable. Triangle UVW is congruent to triangle YXW, and that should be YXZ, not W. And X is 3. So if we look at the congruent statement that we gave, VW is the last two, and XZ are the last two in the other one. So these two segments are congruent. So X is 3. So segment XZ is equal to 3. And then UW is the first and the last in triangle UVW, and YZ is the first and the last. So this one and this one have to be the same. So X minus 1 is the same thing as 2. So if I add 1 to both sides, I'm going to get X is 3. But X minus 1 is supposed to be equal to 2, and we knew that X was 3. They told us that. So this side is equal to 2. So ZY is 2. And then our third side is UV, and those are the first two listed in that triangle. And YX is the first two in the other triangle. So 3x minus 5 has to be the same as 4. And if we plug in 3 like they told us, that would be 9 minus 5 is 4, and that would be true. So segment XY is going to be equal to 4. And then we can prove that those two triangles are congruent by side, 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 since we just said that all three sides are congruent. Then we're going to look at the next picture here. We have triangle DEF and triangle JGH, and they're telling us that Y is 7. So DE is first in the first triangle, so DE is here, and JG is the first one in the second set. So 2y plus 1 is equal to 15, and they're saying y is 7. So that would be 14 here. 2 times 7 is 14, plus 1 is 15. So that is true. So segment JG is equal to 15. Then we have this angle here listed as 12y plus 42, and angle E listed as 126 degrees, and we know they go together because they're both the middle letter of our triangles. So 12 times 7 plus 42 should give us 126. And 12 times 7 is 84. And when we add 42 to that, we do get 126. So that is true. So angle G is equal to 126 degrees. And then our other side, this is 24, FE, and those are the last two in that triangle listed, and GH is the last two in the other triangle, so that's this one. They're saying if we take y squared, so that would be 7 squared minus 4 times y, which is 7, plus 3, we're going to get 24. So this would be 49 minus 28 plus 3 is equal to 24. And 49 minus 28 is 21, and then we have to add 3, so we get 21 plus 3 is 24. So those work out. So segment GH is 24 units, and then we have side, angle, side. So we prove that those two triangles were congruent based on side, angle, side.